Alright, so I've been getting some questions about why I'm changing the steering geometry and design on the front suspension of my Honda. So I'm going to go over a few little things here. I apologize if it's a little glitchy. I'm using the Microsoft screen recorder and it doesn't let you switch screens, so I got to stop and go each time. But essentially the big problem is you've got your kingpin inclination angle, your steering axis. It goes through your upper ball joint, your lower ball joint, and then projects on the ground. The distance from that projected point to the center of your tire is a scrub radius. Now all your forces go through the center of the tire patch, so imagine pushing or pulling on this point. It's going to create a torque around this point that's going to want to make it rotate. And the problem I have is, let's say this is stock. My Honda came with a plus 50 wheel offset. I went to a plus 18, so that's an extra 32 mils out here. And then I have a 35 mil spacer, and so that pushes me all the way out here. Now I have this huge moment arm, and I'm shooting for about 800 wheel horsepower, so that's a significant increase in power. And obviously not all of it's going to go through the front as I'm converting to all-wheel drive, but some still will. So it's going to be a lot of forces, and those forces have to be counteracted by the steering system. So a couple things you can do to fix it is, obviously you can, if you're able to, you want to just translate this whole axis over. But most of the time you can't do that. So what you can do is you can make this arm shorter, and it'll increase the inclination angle, but then higher steering angles can cause other issues that we'll go through later. And so what I'm going to do is convert to a virtual ball, and I'll give you an example of that now. Okay, so my Honda has a standard single upper control arm. It's interesting that Hyundai went backwards. It could have been for cost or packaging reasons, but generally the virtual steering axis has a lot of advantages. They just may not have known what they were doing, because in text later on they say that the simplified steering axis is preferred, but that's, you really got to know how to tune it and know how it moves through dynamic events to get what you want out of it. But so what you do is you essentially break this apart and you give each side of the arm a ball joint. And so if you can only go this far inboard on the system, on a traditional single ball joint arm, your axis has to go through that point. But what you can do is you can actually project that point further in by separating these. And here's kind of a better example of how that works. You've got your single upper, and then on the lower, your ball joints end here, but you're able to project further out. And I've got some examples in SolidWorks that I'll go over to kind of show how that's really an advantage. So what I've done here is I've made a single ball short long on suspension and a virtual ball that's essentially the same. So these dimensions don't represent the CB7 Honda Accord at all. I freehanded all of this and then just put proper wheel dimensions in for reference. So you've got your lateral arm, your lateral link. Most of your handling forces go through this link. And then you've got the tension strut or tension rod, comfort link. There's many names for it, but this essentially just attaches to the front of the cradle or the front of the car, and attaches specifically on my Honda to this link, and it prevents this link from swinging under tire forces. You've got your inner tie rod or your steering rack here, and your outer tie rod. This is kind of the steer arm, this is the knuckle, and again the tire. And we've got the tire center point right here. This is the wheel offset, and that's the spacer I have. And so as we move this, you'll see it rotate around this lower ball joint. And what you can see is how the center of the tire, right here, moves around that ball joint. So it's pretty easy. It's just a singular pivot. Nothing else in this whole system moves, right? So it's just a singular pivot. And what you end up with is, in 2 dimensions, we're going to focus on 2 dimensions. In 3 dimensions, you've got, an upper ball joint that, let's say, it's more inboard and it's here. And so you're going to translate through the upper, through the lower, and project somewhere on the ground. So really your scrub radius is somewhere in here to this center point. But for this exercise, we'll just focus in 2 dimension. So your scrub radius, again, is this distance, and any force that goes through the tire patch is going to be multiplied by this distance to give a torque. And in this system, the only thing reacting to the torque is the tie rod. So all that force goes back through your steering system. Whether you're accelerating or braking, a force is going to push on the center of this tire, and it's going to cause the wheel to want to rotate, whether you're accelerating or braking. And so that's just a simplified single arm or single ball joint lower. And then what we're going to do is we're going to switch to a virtual. So I've kept everything the same with the exception that I've taken this tension link or comfort link and I've detached it from the arm here and given its own ball joint on the knuckle. And now when we move the system, it doesn't translate as much, and what you'll notice is this projection it's the virtual rotation axis of the system. There are some downsides to this, which I'll go over once I have a more complex or more properly designed system. But as you'll notice, as that ball joint moves around, you can see, for example, this point doesn't move as much, and that's because it's rotating around a lower distance. And as it's over here, it moves a lot more. There are some issues you can get into, which I'll go over at some point, but if you notice, these forces are going to act through these arms in this direction. So let's say you're steering in, and the car wants to turn out, and so you're fighting the car turning out as you're steering in. But then all of a sudden you get to this angle and you have high enough load that now the force from the tire, it's no longer pushing this direction between these ball joints. It's now going to push behind this rear ball joint and actually cause the torque moment to flip. And so you're going to be steering in and the car is going to want to be straightening out, and all of a sudden the car makes itself want to turn in. So we want to avoid that in our design, which I'll make sure I do. But you'll notice this center point here, instead of swinging back and forth, is it swings a lot less. Not only have we cut our scrub radius, which was originally here to here, we've now cut it from here to here, and it's nearly half, if not close to. So not only have we reduced the torque by half, that goes onto the knuckle, further reducing forces here, so it's a little bit more stable under acceleration and braking. And now I have a two-dimensional kind of 3D model to show these points overlaid. So now what we have here is we have both systems overlaid. You can kind of see, let me straighten them out. So that's both systems perfectly overlaid. There are 2 tie rods, outer tie rods. There are 2 wheel tire knuckle assemblies. There are 2 lateral links. One is connected to this, and then there's this one comfort link or tension link that is attached to another spot on the knuckle. So now as we move the tie rod, you can see that this point doesn't move, so you can almost use that as a reference point for the migration of the wheel center. You can see that as we go through the steering, the single ball joint tire patch is migrating fore and aft, so your wheelbase is changing substantially. where the virtual ball joint, your wheel center is migrating significantly less. And that is kind of one of the advantages, is instead of it rotating completely around, these reference points are moving back while that reference point moves forward. Now, one of the other advantages can be packaging. Let's say I have really tight clearance, which I know I will, to the body, the fender, what have you. This tire is going to rotate more about its center with a virtual ball than a single ball. And you can see that I need less clearance with a virtual ball than a single ball. And it's essentially the distance between these centers as the tire gets pushed more forward and backwards. That's a significant difference in migration. At these tight angles, it doesn't matter as much, but it will help the torque steer and brake dive significantly. So I'm going to go through and actually properly develop the geometry. I'll try to get as close to my factory hard points as I can, but of course I'll change them if needed. But yeah, so I hope this answers questions I was getting from people of why I would convert to a double ball joint setup, how it helps. I had some people commenting on how I'm just going to destroy my power steering pump. So if I tune this right, the forces shouldn't be significantly greater than the factory steering forces if I tune it right. So yeah, follow for more updates and feel free to ask questions.